In our second chapter, we will cover the basics of database and database management system or DBMS. We will explore what databases are, why they are important, and the different types of a DBMS available. Next, we move into the SQL database. We will explain the relational databases and the fundamental of the SQL, how to use the SQL to manage and query data efficiently. Then we can move into that NoSQL databases. So we will discuss the various types of a NoSQL database, uh, such as the document store, key value store, column family store, graph databases, and explore their use cases. Then we can move into the SQL versus NoSQL database. After understanding the both SQL and NoSQL, we will compare these two database types. You will learn about their strengths and weakness and when to use each type of depending on your project requirement. Then we can move into the database replication. Database replication is a crucial for data availability and redundancy. We will cover the different methods and strategy for replicating the database to ensure your data is always accessible and safe. Then we can move into that indexes. Indexes play the main role for optimizing the database performance. We will explore the importance of indexing and how index works and how to implement them effectively. Then we can move into that normalization and denormalization. Uh, so, uh, Schema design is a critical for the database efficiency. In these sections, we will discuss the normalization and denormalization technique to optimize your database schema design. Then we can move into that and base consistency model. The consistency model define how transactions are handled in the database. We will dive into the acid model and which ensure the reliable transactions and the base model which is often to use NoSQL databases. Then we can move into that CAP theorem. Understanding the CAP theorem is essential for the distributed system. We will explain the trade-offs between the consistency, availability, partition tolerance, and helping you make inform the decisions for your database architecture. We can explain the Pearsall's theorem. Building on a CAP theorem, the Pearsall's theorem introduce the latency consideration. We will discuss how this theorem extend the CAP and its implication for the database design. And we can move into the transactions. Transactions are the building blocks of the reliable database operation. We will cover the concept of a database transactions and ensuring you understand how to maintain the data integrity. Then afterwards, we can discuss about the distributed transactions. In the modern system, handling the transaction across the multiple nodes in the common. We will explore the distributed transactions and the techniques used to maintain the consistency in these environments. Then afterwards, we can explain the sorting. So sorting is the technique for horizontal partitioning of the database. We will explain how sorting works and how to implement it to distributed data across the multiple server efficiently. Then we can explain the consistent hashing is used to database a distributed database evenly across the node. We will cover the principle of the consistent of hashing and how it helps in maintaining the balance loads in the distributed system. Then we can explain the database federation. In the this method to integrate a multiple database into the single system, you will learn how to manage and query data across the different database seamlessly. And that's for today. Thank you for joining us on the journey through the database and database management. Don't forget to like, subscribe, and hit the notification bell to stay updated on our latest video. See you in next chapter.